This brief video will address how to apply molar volume in molar volume type problem solving when we're not at STP conditions. Just a reminder, molar volume is applied with gases, and when we are referring and say molar volume, we mean 22.414 liters per mole, liters of gas for any 1 mole of gas, but it has to be at STP conditions. All right, so we are going to work a problem that's actually in your unit packet. So if we would be under the category of molar volume problems, that tells you we've got to use 22.414 in our problem solving. All right. If you look at number 8, we're asked for molar mass. Reminder, units are gram per mole. We know, and you know you don't have to write down givens. We know the mass of our gas. We know the volume. And we are not at STP. All right. And we know, we can see what we're going to find. Okay, so what do we do? How do we solve this knowing that I'm asking you in some way, shape, or form to rely on molar volume? Well, what would change here? What would change about our gas if we were at STP conditions? Mass does not change. Mass does not, it's not temperature or pressure dependent. We know that standard temperature is 0 Celsius and standard pressure, 1 atmosphere or 760 millimeters of mercury. Well, if we were at this temperature instead of this, or this pressure instead of this, our volume would change. These are our given conditions. To be able to use molar volume, we need to adjust our volume to be at STP. So we first, before we can get our answer, need to apply the combined gas law. All right. We know that this needs to be in Kelvin. And I will just show us. Oh, sugar. I'm going to just quickly go ahead and I'm pretty sure that I have this worked out. Oh, nope. Oh, yes. So, when we plug and chug, we get 345 milliliters. Okay, so there is the application of the combined gas for that problem. All right, but we still do not have our molar mass. So what do we know? Well, we know that we've corrected our gas to have that volume at STP. And we know we have 1.39 grams. Now, at this point, we could go different ways. You can create a conversion factor as long as you have relatable material. And it is true. 1.39 grams of this gas will occupy 345 milliliters at STP. So that is okay. I do not want, though, gram per milliliter. I want gram per mole. I am at STP, so I can apply molar volume. And milliliters will cancel, liter cancels, ta-da! And the answer that we get is, I calculated 90.3. Now, what you could do though, knowing that we need molar mass, which will be gram per mole, what you could do is use this 345 mils that you found, and then just apply molar volume to get this 2 moles. And then this applies here, and we will get the identical answer of 90.3 gram per mole. So the situation is that if we're not at STP, it's our volume that we need to adjust, and we'll apply the combined gas law to do that.